Hello, students. How are you? Good evening to all. I hope now it is pretty much clear to my voice and the screen. Oh, hi, Devan. How are you? Oh, hi, Niranjan. Hi, Charanya. Let's just wait for 1 minute more. Okay. Hi, Pratibha Chauhan. How are you? Okay. So if the screen in the meanwhile, the screen is visible and I'm audible to you, then please write this in the chat box. Okay. Just a second. Huh? Okay, Devan. If this screen is clear and voice is audible to Devan, I am considering कि सभी को ये screen visible होगा and I am audible to everyone. So without wasting so much time as I have wasted, let's just get started. Okay. Yeah. So hi Swati, how are you? So here we are with the lecture number 9 of geometrical optics, also known as ray optics. ठीक है और yeah. So yeah. So today it's a lecture number 9 for geometrical optics. What is our aim for today? Firstly, we will do some recall as we do in our lecture. Yeah. Then after we learn about the combination of two thin prism. After that, spherical refracting surfaces we would cover. Then the relation between object distance and image distance for refracting surfaces. Then after we are going to learn about the lens and its type. And then lens formula and magnification, like the same we have read for the plane mirror or spherical mirrors. Okay, we have learned something about the lens formula and magnification in spherical mirror. So the same thing we are going to do with this lens type. Okay, the lens formula and magnification. Then in the last we are going to see the power of lenses. Okay, so that is it for today. So let's just get started with it. Firstly, in the previous class, I have told you about dispersion. Na? What is dispersion? It is just the, yeah. So if we have white light is nothing but the combination of 7 colors light, na? With your pattern we have. So what is happen when white light passes through a thin prism? Prism, what is prism? Prism is a refracting surfaces. Okay, they are non-parallel to each other. Okay, and we have some material inside that with a specific refractive index. Got it? So here, this is the prism we have. What is dispersion? Then a visible splitting of white light, splitting of visible light into 7 different colors. And this phenomena is termed as the dispersion. Okay? Why it is happening? Why? What is the cause of dispersion? Cause of dispersion is the, just a second. Cause of, अरे यार, just a second. Cause of dispersion is, you guys tell me what will be the cause of dispersion. Write this thing in the chat box. The cause of dispersion is the wavelength of light. Wavelength of light. ठीक है? So this is the cause of dispersion, because the wavelength varies as the refractive index of the material varies. Okay. So more is the refractive index, more is the, we have seen this formula. This is the deviation is equals to mu minus 1 time A. It is the deviation from thin prism. So in this formula, you will see ki mu is directly dependent on delta. And from this formula, what we have learned is ki mu is nothing but C by V, and V is nothing but n lambda. So mu is directly dependent to 1 by lambda. ठीक है. So जिसके लिए lambda ज्यादा होगा, mu will be lower. As mu lowers, then delta will be low. ठीक है. Means जिसकी जितनी ज्यादा wavelength, उसका उतना कम deviation. That is why the red color showing the minimum deviation. ठीक है. If you try to measure the angle, na, so this red color is coming farthest, and this violet color coming initially at the starting, because the violet color has wavelength of violet color is greater than, sorry, is less than wavelength of red color. So if the wavelength is lesser, then mu of violet will be greater than mu of red. If mu of V is greater than mu of red, then delta of V is greater than delta of R. That is why the red color deviate less, and that is the reason we all the sign like खतरे वाले जो sign होते हैं, danger sign, will be painted as red, so that it will be visible to you from a far distance away. That is why the color of brakes light in any vehicle is kept red, and that is why the signal in traffic light to stop is red, so that it will be visible to the far distance. Okay, got it? So this is the dispersion that we have learned. Now we have learned also about the condition for grazing emergence. Grazing emergence क्या था? If this is a prism, a incident ray comes to it, then after refraction of second boundary, it move along the interface. This is grazing emergence. Grazing emergence. Grazing emergence के लिए condition क्या थी? What should be the condition? Condition is angle of emergence is 90 degree, and this angle R1, or sorry, R2 should be theta c. When R2 has a value of theta c, then we have the condition for TIR, na? ठीक है? On the angle of critical angle पे, the emergence angle or the angle of refraction would become 90 degree. Means there is no ray which entering into the material, second material. It grazes only from the boundary. ठीक है? Along the boundary. Now what is the condition for no emergence? I have told you the condition for no emergence is when this R2, minimum value of R2 is greater than theta c. ठीक है? Is greater than theta c. Got it? Means when the minimum value of R2 is greater than theta c, then there is a condition that no ray would transfer to another medium. Okay, complete TIR can take place on the boundary. Okay, look, this is the boundary we have, and this is the ray coming. Okay, this is R2. Let's say if this R2 is greater than theta c, the minimum value of R2, इससे कम और हो ही नहीं सकता R2, और जो कम है, जो मिनिमम है, द मिनिमम वैल्यू ऑफ R2 इज ग्रेटर देन थीटा सी, मीन्स और जो हायर वैल्यूज है वो तो और ज्यादा बड़ी होंगी थीटा सी से, ठीक है। सो minimum value of R2 is greater than theta c, means there is TIR taking place, ठीक है, got it। इसमें आप नोट भी कर सकते हैं, I would like to note this point, total internal reflection takes place, okay। What is the formula for deviation by thin prism? I have told you right now in the earlier slide. It is delta is equals to mu minus 1 into V. Not V, it is A, where mu is the refractive index of the prism and A is the angle of prism. Got it? What is the deviation for violet color? It will be mu V minus 1 into A, because here we are dealing with the visible region of light. It is the abbreviation for Webb Geor. So try to learn it, na? Violet, indigo, blue, green, yellow, orange, red, and these are the fundamental colors, ठीक है। Del R, what is the value for del R? It is mu V minus 1 into A, sorry, mu R, got it। So this is the deviation by thin prism, thin होना चाहिए prism, and what should be the condition for thin prism? This angle of incidence, angle of emergence, R1, R2, all the angle should be very small. Got it? Now the combination of two thin film that I have to talk about. Anything left, na? No. One thing more that I want to discuss that we have done in earlier lecture is the dispersive power. Dispersive power. Okay, so what is the formula for dispersive power? It is represented by omega, which is what? Theta by, yeah, Samsung Lab 2. What is the issue? Now, whatever you have, like doubt kind of thing, you can write this thing in the chat box. Okay. And I'm saying it, all of you. Okay. All of the students that have joined. If you have any kind of doubt, you can ask in the chat box. Okay. So what is dispersive power? Dispersive power is angular deviation divided by mean deviation. Okay. And what is angular deviation? It is the difference of mu v minus mu r into a. ठीक है, this is the angular deviation that we have, del v minus del r, or if you put the values of del v and del r, you will get this as mu v minus mu r into a. And what is the value for del mean? Del mean is, what is the value for del mean? It is del of violet plus del of red divided by 2, which is approximated at del of yellow, del of mean. So mean deviation is approximated at the deviation of yellow color. Okay. So Samsung Lab 2, if you have any doubt, na, please write this thing in the chat box. Okay. So combination of two thin prism we are going to discuss. Here you will see the one prism is placed like this and other is the inverted one. Got it? So the ray is traveling from there here it is deviating, moving towards the normal, entering in the thick region, optically denser region, again moving away from the normal, again entering in this and moving in this direction. Got it? So here there is like, it's a little bit of conceptual thing. Okay. So first thing we are going to do dispersion without deviation by the combination of two thin prism. Okay. What should be the value of dispersion without deviation? Okay. Deviation we are representing by, deviation is represented by delta, or dispersion is represented by theta. Okay. Got it? So in this concept, we are going to see if we combined two thin prism, what should be the value of deviation if we do not consider, what should be the value of dispersion if we do not consider deviation. Okay. So if I talk about what will be the value of deviation here, it is del 1 plus del 2, deviation by one prism number 1 and deviation by prism number 2, and that is the concept that we are learning since the first lecture. The deviation by thin prism is also del 1 plus del 2. Okay. Spherical lab, or sorry, glass lab is also del 1 plus del 2. So here we have two material, so we have two type of deviation. Okay. Now del is equals to, what should be the value of del v, del 1 here? So del 1 is nothing but, these are thin prisms, so mu minus 1 into a, and it is mu dash minus 1 into a dash. I have considered this angle as a dash and this is as a. Material of this prism is mu and material of this prism has refractive index mu dash. Okay. So we are considering that deviation is not playing any role here. So we would do deviation as 0. So mu minus 1 into a plus mu dash minus 1 into a dash equals to 0. What should be the value of a dash here? A dash is nothing but mu minus 1, mu dash minus 1 into a, और साथ में आएगा negative. Here this negative sign appear because of inverted prism. ठीक है, प्रिज्म को उलट दिया ना, so that is why this negative sign here appear in the deviation. ठीक है, got it? So what should be the value of dispersion? Dispersion here is theta is equals to theta 1 plus theta 2. We know that omega 1 is equals to what? What should be the value of omega 1? It is the dispersive power that we have discussed. Dispersive power is angular deviation or dispersion divided by mean deviation. Okay. So we can write from here, because the deviation that we are considering here, this del 1 and del 2 are the mean deviation, del mean for prism. Okay. So we can consider that omega 1 as theta 1 and it is del 1. Instead of writing mean, I am writing it as del 1. And for omega 2, it is theta 2 by del 2. Okay. So put the value here. what is the value of theta 1? Just cross multiply this thing. We will have omega 1 del 1 plus omega 2 del 2. Okay. Now we have the value of del 1 and del 2 here. Okay. Del 1 and del 2 play no role in this concept. Got it? Because we are considering this, in this concept, we are seeing the dispersion but without deviation. Got it? So theta, finally we have omega 1 del 1 plus omega 2 del 2. This is a formula you should keep remember, or you should note this down. Okay? Yeah. One more thing you can do here for the simplification of this. What you will do, from the discussion that we have done, that del is equals to del 1 plus del 2. So del 1 plus del 2 here is 0. So you can put del 2 is equals to minus of del 1. So here theta is equals to omega 1 del 1 minus of omega 2 del 1. And this implies as theta is equals to omega 1 minus omega 2 into del 1. Okay, so this is the final formula. Note it down here for not. Okay. If you have any kind of doubt in this discussion, in this formula, you will ask in the chat box. Okay, write this thing in the chat box. Okay. Now, the next topic, I hope you note this down. Okay. The next topic is deviation without dispersion. Okay. In this thing, it is also topic for thin prism combination, but here we are interested in deviation, not in dispersion. So for that, we would know what is the deviation. It is del 1 plus del 2. And what is dispersion? Theta is equals to theta 1 plus theta 2. But here we are not considering dispersion. So this theta will result in 0. What is the value of theta 1? What is the value of theta 1? You will see in the previous slide, the theta 1 here is omega 1 and del 1. And here it is in terms of omega 2 and del 2. But we know that theta 1, we have considered the angular deviation. What is the value of that? It is the difference of refractive index of violet minus refractive index for red multiplied with the angle of prism. Okay. Put this value. So for theta 1, it is mu v minus mu r into a plus 4 theta 2. It is mu v minus mu r, and you put the dash over it. Okay. So what should be the value of a dash here? A dash is nothing but mu v minus mu r in mu v dash minus mu r dash minus of a. Okay. Or you can say it, a dash is equals to minus of mu v minus mu r divided by mu v dash minus mu r dash into a. So this is the formula for angle of prism, second angle of prism. Okay. We have combination of two thin prism over here. One is placed inverted. Okay. And this negative sign indicate that this second prism is inverted, because this a dash is representing the angle of second prism. This a is angle of first prism. Okay. Now, what is the value of, we are interested in deviation. So del is equals to del 1 plus del 2. Okay. We want to put the value of del 1 in terms of theta 1. Okay. In terms of theta 1. So how do we put it? Yeah, from the formula that I have discussed, the dispersive power is theta by delta, delta mean. Okay. So from this we can write as del is equals to omega 1 is theta 1 by del 1. So del 1 here is theta 1 by omega 1. ठीक है. Similarly, del 2 is theta 2 by omega 2. Okay. Put this value here. We have theta 1 by omega 1 plus theta 2 by omega 2. From this equation, equation number 1, we can say that theta 2 is equals to minus of theta 1. Put the value of theta 1 here. So you will have delta is equals to 1 upon omega 1 minus, just a second, minus 1 upon omega 2 into theta 1. Okay. So this is the final formula to knot. Okay. I hope you got this. Okay. These are the very simple formula. If I write the first formula over here, what is that? Theta is equals to omega 1 minus omega 2 into del 1. So in this formula, theta is replaced by delta, omega is replaced by 1 by omega, omega 2 is replaced by 1 by omega 2, and del 1 is replaced by theta 1. Got it? So yeah. Now the spherical refracting surfaces. What is the refracting surfaces? That can reflect the light. Any transparent medium through which the light can travel behaves as the refracting surface. What special about spherical refracting surface? Like you have a cylindrical rod made of glass, okay, and it is sharp at the end. A rod, you have seen it, okay. A rod will look like this. This is the spherical rod, okay. Now what about this? Is the plain rod, we can say. If you see the side view of this thing will appear to you like this. Okay. What if I sharpen this, if I cut this surface, the end surface, if I cut this, so what will happen? Instead of looking a flat one like a rectangle, if I cut this surface in this direction, it will appear to me like that. So this is the refracting surface. This refracting surface is nothing but it is a part of sphere. Okay, like a mirror. Mirror is also part of sphere. So this refracting surface is also a part of sphere. It is similar to that. If you have a material which is curved from one side, okay, and plane from one side, you will see in the next discussion this type of surface you have, and if you attach this surface to a cylindrical rod, so this merge will give you like a shape of like this. Okay. So a spherical refracting surface is nothing but what it is. It is a part of sphere. Okay. Cylindrical glass ko we have curved inside and outside. So we have two types of refracting surface. First is the convex and second one is concave. If this bulge is going outward, okay, or you can say the one thing you can remember, if the center of curvature, this is the part of sphere and I'm drawing that sphere. If center of curvature lying inside the material, that surface is termed as convex. Convex surface. And in total, it is convex refracting surface. And if the center of curvature lie outside the surface, then it is termed as concave refracting surface. ओके, अब मैं यहां पे लिख भी रहा हूं, सेंटर ऑफ कर्वेचर लाई इनसाइड, सॉरी lies outside, okay, and center of curvature lies inside. Got it? So these are the two surfaces that we have. Now we are going to see the relation of, if we place an object here, so it definitely forms some image of it. So what is the relation between the object distance and image distance if we place this object in front of a refracting surface? So that relation we are going to derive, and we would see what are the assumption that we have to make, okay, and how we will move through it, okay. So firstly, all the calculation in your syllabus will be based on the paraxial rays, okay. And what are the paraxial rays? The ray which are very near to the principal surface, the principal axis, okay. तो मैं यहाँ पे पहले नोट डाउन कर देता हूं, रेज आर पैरा एक्सियल, ओके, yeah, this angle is alpha, this angle is beta, this angle is gamma, ठीक है. This is the incident ray falling on this curved surface. If I draw the normal to this surface, it would definitely pass from the center of curvature, because any line drawn perpendicular to the surface of sphere will pass through its center, okay, and behaves as the radius of it, okay, and if connects the both end, it will become the diameter, okay. So here this line would join the surface at the center of curvature of this refracting surface, okay. This height is h, this height you will see, this point is p, the pole geometrical center of this spherical surface, and this p dash is the point of where this perpendicular cut the principal surface, okay. This angle of incidence is theta1, let's say, and this angle of refraction here, it is theta2, okay. So firstly we would see some relation. This point is object point, this point is image point, okay. This p, this point is normal point, yeah, all point has its name, okay. So in triangle ONC, in triangle ONC, this is the triangle ON, O to N, N to C, ठीक है. So in this triangle, this theta1 behaving as a exterior angle, and you will know in a triangle, if these are the angle, like I say A and B, and this is the exterior angle C. So you can say that this exterior angle is the sum of the internal angles. Okay, got it? So here I can write theta1 is nothing but alpha plus beta, equation 1. If anyone has any doubt, can ask right now. Okay. In triangle, next triangle that we are going to consider is this NCI. Take a careful look of it. NCI. Okay. In a triangle NCI. Okay. In triangle NCI, what do we have? Again, we are going to apply this theorem. Sum of the interior angle equals to the equals to exterior angle. So here the exterior angle is beta, if you will see, and the interior angle are theta 2 and gamma. So we can write that beta is equals to theta 2 plus gamma, so that we have theta 2 is equals to beta minus gamma. This is our equation number 2. Okay, got it? Now, since rays are what? Paraxial. Okay, so this whole angle alpha, beta, theta 1, theta 2 and gamma are very small. Okay, are very small. This point P dash and P can taken as same point. ठीक है, because जैसे जैसे ये अल्फा छोटा होता जाएगा, this point would come here, this point would come here, and this देखो, this P dash is approaching to P. ठीक है, so that is why I have mentioned this P dash and P can be considered as same. ठीक है, so based on that data, we are going to apply the tan alpha in triangle ONP, or would say P dash, because P and P dash are same. So tan alpha, what should be the value of tan alpha here? Tan alpha is perpendicular over base. This is the object distance from the pole, which is considered by U. And from the pole, the distance of image would be considered as V. And from the pole, the center of curvature is as of a distance of radius of curvature. Okay? So tan alpha here is H over U plus U ki minus U. Tell me, plus U ki minus U. It should be minus U. Why? Because we are measuring this distance in the direction of refracted ray. Okay? Have you remembered that sign convention that I have told you? All the distances measured in the direction of incident ray, consider positive, otherwise negative. So the U is the distance which is away from the surface also, and it is in the direction of refracted rays. Okay, reflected ray. Got it? So this would be minus U. Okay. What is the value of tan beta? Tan beta is nothing but H over, we are applying in the triangle NPC, tan beta. Okay, H over R. R is taken as positive because it is measured in the direction of incident ray. And what about tan gamma? So it is H over in triangle NPI. Tan gamma is H over V, the distance of image from the pole. And V would be considered positive, measured in the direction of incident ray. ठीक है. So we have these values 10 alpha, 10 beta, 10 gamma. Got it? Now apply Snell's law. At the boundary. So refractive index of outer medium I would consider as mu1. Okay. And refractive index of this material, this glass, would be considered as mu2. So what is Snell's law? Mu1 sine angle of incidence theta 1, mu2 sine angle of incidence, angle of refraction theta 2. Since these angles are very small, so I am making the assumption here. So sine theta 1 consider as theta 1, sine theta 2 considered as theta 2. So it is mu1 theta 1, mu2 theta 2. Okay. Put the value of theta 1 and theta 2 from equation number 1 and 2. It is mu1 alpha plus beta equals to mu2 beta minus gamma. Okay. ठीक है. Now, since alpha, beta, gamma is also very small, so you can consider 10 alpha as alpha, 10 gamma as gamma, and what have left? Beta, 10 beta as beta. So put the value of alpha, beta, gamma here. It is 10 alpha, 10 beta, 10 gamma. What is the value of 10 alpha? It is h by minus u. Put them one by one. Mu1, what is the value of alpha 1? Alpha, it is h by minus u plus beta h upon r equals to mu2. What is the value of beta? H over r minus h over v, the value of 10 gamma. ठीक है. H would be taken as common from both the side and will cancel out. So it is only mu1 minus of mu1 by u plus mu1 by r equals to mu2 by r minus mu2 by v. We would take mu v here, mu2 by v here. So it is mu2 by v minus mu1 by u equals to mu2 minus mu1 divided by r. So this is the final formula that we have. Here mu2 is the medium in which ray is going and mu1 is the medium from where the ray is coming. Okay. Same as of the condition for real depth and apparent depth. Okay. Okay. So this is the formula. If you have any kind of doubt in this concept, you can ask in the chat box. Okay. Otherwise, we will move on. Okay. Have you got this? Okay. Just write in the chat box now. Okay. So here you would have the formula mu2 by v minus mu1 upon v equals to mu2 minus mu1 by r, where r is the radius of curvature. ठीक है. यहाँ पे मैं लिख भी देता हूं mu2 is the medium from where the ray is going. ठीक है. And mu1 is the medium from where the ray is coming. And obviously, if you just put some stress on this concept, from where the ray can come? Ray is coming from the object na, and going through the observer. So mu1 is nothing but the medium for object. Okay. Now moving on to the next. Okay, Pratibha Chauhan, you have no doubt. It's good for you. And you are taking this lecture seriously. It's good. Now you will solve this numerical. If you try to solve this numerical based on the data, based on the concept that I have told you, the fresh one. Okay. So in this, we have to use the formula mu2 minus mu1 by r equals to mu2 by v minus mu1 by u. Okay. Let's try to solve this question. I'm giving you 1 minute to solve this question. Okay. And your time starts now. You have a convex surface of radius of curvature 40 centimeter. Separate two media of refractive indices 4/3 and 1.5. An object is kept in the first medium at the distance of 20 centimeter from the surface. Calculate the position of the image. Try to calculate the position of the image. Okay. You have 1 minute to solve this question. Okay. Okay. So in this question, what is given? Given that R की value, R is 40 centimeter. इसमें क्या कहा गया? The separate two media refractive indices 4/3 and 1.5. Object is kept in first medium, and first medium is of indices of 4/3. Means here mu1 is 4/3, where the object is placed, from where the ray is coming. So it is mu1 4/3, mu2 1.5. Okay. What is the value of u? An object is kept in first medium at a distance of 20 centimeter. So u here is minus of 20 centimeter because it is kept from distance. Answer is 24 centimeter. Let's see, Pratibha Chauhan. It's good you are solving the question. It's very good. Okay, so object is placed somehow here at a distance of minus 20 centimeter. Okay. Yeah. Put the values in the formula. Mu2 minus mu1 by r equals to mu2 by v minus mu1 by v. Mu1 by u. Mu2 is 1.5 minus 4/3 is 1.33. Okay. Divided by what is the value of r? It is 40 centimeter. Equals to what is mu2 by v? Mu2 is again 1.5. V we have to calculate minus. Yeah, mu1 is 1.33 divided by what is the value of u? It is 20 minus. So this minus and this minus would become plus. Okay. If you try to calculate this, 1.5 times of v is equals to, it is point. If you would consider it 1.3, it would be easier for us. 0.2. Okay. Got it? Divided by 40 minus again 1.3 divided by 20. Take the LCM 40. We have 0.2 minus 20 to the 40. 2 will be multiplied in 1.3. It will be 2.6. So it is minus of 2.4 divided by 40. 1.5 times divided by v. And if you would calculate that, it would give you the value of v as minus of 24. Okay. minus of 24 centimeter. So you are right, Pratibha Chauhan. Answer is 24 centimeter. But the object has its image in the side of the reflected rays. So the distance is of the image is minus 24 centimeter. Got it? Yeah. So the next thing we have lenses. What is a lens? We are going to discuss. You have seen that we are wearing glasses, sunglasses, and so बोलते हैं ना नजर का चश्मा जो लगाते हैं लोग, ठीक है? They have difficulty to see the objects, see the picture, and see the by in the reading. They are also having problem. So they would use a lens, which is also called as spectacles. Okay, so that would be made of the lenses. You have heard about it. Now what is a lens? Lens is a transparent medium. Okay, homogeneous transparent medium, solid medium also. But the condition for any surface or any transparent medium to be a lens is that one of the surfaces of the lens should be curved. Okay? And it is not the random curve. This curve would be a part of a sphere. Okay? That would cause the lens. Okay? So it is a homogeneous, solid, transparent medium bounded by two media. Okay? Bounded by two surfaces. Okay? And one of the surfaces must be curved. Okay? Based on the data, we have two types of lens, convex lens and concave lens. Okay? What is a convex lens? Convex lens is also termed as converging lens. And concave lens is also termed as diverging lens. How it is so? Convex lens is this, you can see, in which the middle portion of the lens is bulging out and the corner are near to each other. You can see it here, no? The middle portion is somehow bulges out and the corner is small. Okay? In this, you can also learn it as like in convex lens, I have middle portion thick and corner part is thin. In concave lens, the corner part is thick and the middle portion is thin. You can see it here. This is concave. This is convex. Although we have convex lenses also have its type. This is the type. One type convex lens. It is also termed as double convex lens. Double convex lens. It is biconvex lens in which the radius of this curve R1 equals to radius of this curve. R1 is equals to R2. But in this R1, the radius of this curve is greater than radius of the other part. Okay? This is the plano-convex lens. One surface is plane. Now, any one of you, if tell me what is the radius of this surface, this plane surface, I would consider that person genius of the group immediately. Okay? Tell me in the chat box, what should be the radius for this plane surface? What should be the radius for this plane surface? Pratibha Chauhan, Devan, any one of you. Okay. And this is also a convex lens. Okay. In this radius should be R2 should be less than the R1. ठीक है, तभी तो ये जाके मिलेंगे ना यहाँ पे. Okay. Any one of you tell me na, what should be the radius of this plane surface? Pratibha is there. All of you are there na? Tell me. Till then I will cover the diverging lens. So this we have concave lens or double concave lens. It is concave lens. R1 is equals to R2. Plano concave lens. One surface is plane, other surface is curved, and this is the negative Menaceous lens. Okay, in which the radius of curvature of this part, let's say radius of curvature of this part R1 and radius of curvature of this part. So R1 is always greater than R2. That is why it is not going to meet anywhere. Okay. So these are the types of lens. Why we are saying that convex lens is converging? Because if the parallel beam of ray passing through this lens, it converges the light at a point. Okay. For example, this is the concave lens we have, and if the parallel beam of light falls on it, it would converge it at a point, single point. So it converges the beam of light in a similar way, but in opposite manner. This concave lens would diverge the ray. Okay. In everyday life, you have seen the torch, small torch, na? So what would they do? They would diverge the light so that you have a better view and you have a larger covering area. So this is the diverging nature. And this is converging. Okay. Okay. Got it? Now I will tell you, any one of you haven't told me that what should be the radius of this plane surface. I am telling you that the radius of this plane surface would be infinity. Okay. It is a part of a circle which have infinite radius, length of the radius. Okay. Okay. So the term related with lens we would do in the next lecture. Okay. Till now we have covered with lenses, spherical surface relation. So this is it from my side. If you have any kind of doubt, you can ask in the in this. Otherwise, we will move on. Okay. Thank you so much for attending the lecture. It would be nice meeting you guys. Okay. Okay. Take care of yourself and study hard. Okay. Be prepared for your competitive exam. Do as much practice as you can do. ठीक है, ज़्यादा से ज़्यादा practice करो. That is the key to success. If you try, I will tell you a trick. ठीक है, I'm telling you a trick to success in any competitive exam. Na, you will solve each and every type of numerical that has been asked. Variety of numerical पे focus करो. That is the key to success, and that will clear the concept of yours. ठीक है? Okay. Thank you so much.